Alright, welcome to another video in my Python for DevOps series where I read that book by O'Reilly Media. We're going to begin Chapter 10, Infrastructure as Code. Before we had fancy DevOps titles and job descriptions, we were lowly system administrators, or sysadmins for short. Those were the dark pre-cloud days when we had to load the trunks of our cars with bare metal servers and drive to a colo facility to rack the servers, wire them, and attach a wheeled monitor / keyboard / mouse to them, and set them up one by one. Greg still shudders to think about the hours he spent in colos, the blinding light, and freezing AC. In these colo locations, they've got to really crank the AC because the big kind of problem with these centers is hardware failure. They're trying to reduce that problem as much as possible, so hardware fails more often if it runs at higher temperatures, so they just crank the AC to keep the hardware cooler and prevent the frequency at which it fails. We had to be wizards at bash scripting. Then we graduated to Perl, and the more fortunate of us to Python. As the saying went, the internet circa 2004 was held together with duct tape and bubble gum. That's funny. Probably still is. Somewhere during the period of 2006 to 2007, we discovered the magical world of Amazon EC2 instances. We were able to provision servers through a simple point-and-click interface or through command line tools. No more driving to colocation facilities, no more stacking and wiring bare metal servers. We could go wild and launch 10 EC2 instances at a time, or even 20, or even 100. The sky was the limit. However, we quickly figured out that manually connecting to each EC2 instance using SSH and then setting up our applications on every instance separately was not going to scale. It was fairly easy to provision the instances themselves. What was difficult was to install the required packages for our applications, add the correct users, and make sure the file permissions looked right. And finally, install and configure our applications. To scratch this itch, the first generation of infrastructure automation software came into being, represented by configuration management tools. Puppet was the first well-known configuration management tool, released in 2005 and predated the release of Amazon EC2. Other such tools that were launched on the heels of Puppet were Chef in 2008, followed by SaltStack in 2011, and Ansible in 2012. By 2009, the world was ready to welcome the arrival of a new term, DevOps. To this day, there are competing definitions of DevOps. What is interesting is that it came into being in the tumultuous early days of infrastructure software automation. While there are important people and culture aspects to DevOps, one thing stands out in this chapter: the ability to automate the provisioning, configuration, and deployment of infrastructure and applications. By 2011, it was getting hard to keep track of all the services comprising the Amazon Web Services AWS suite. The cloud was much more complicated than raw compute power, Amazon EC2 and object storage, Amazon S3. Applications started to rely on multiple services interacting with each other, and tools were needed to help automate the provisioning of these services. Amazon didn't wait long to fill this need, and in 2011 it started offering such a tool, Amazon CloudFormation. This was one of the first moments when we could truly say that we were able to describe our infrastructure through code. Amazon CloudFormation opened the doors to a new generation of infrastructure as a code IAC tools, which were operating at the layer of the cloud infrastructure itself, underneath the layer served by the first generation configuration management tools. By 2014, AWS had launched dozens of services. That was the year when another important tool in the world of IAC came into being, Terraform by HashiCorp. To this day, the two most used IAC tools are CloudFormation and Terraform. Another important development in the world of IAC and DevOps was taking place sometime between late 2013 and early 2014. The release of Docker, which came to be synonymous with container technologies. Although containers had been around for a number of years, the great benefit that Docker brought to the table was that it wrapped technologies such as Linux containers and cgroups into an easy-to-use API and command line interface (CLI) toolset that significantly lowered the barrier of entry for people who wanted to package their applications into containers that could be deployed and run wherever Docker was running. Container technologies and container orchestration platforms are discussed in details in chapters 11 and 12. The usage and mindshare of Docker exploded and damaged the popularity of the first generation configuration management tools, Puppet, Chef, Ansible, SaltStack. The companies behind these tools are reeling at the moment and are all trying to stay afloat and current by reinventing themselves as cloud friendly. Before the advent of Docker, you would provision the infrastructure for your application with an IAC tool such as CloudFormation or Terraform, and then deploy the application itself, code and configuration, with a configuration management tool such as Puppet, Chef, Ansible, or SaltStack. Docker suddenly made these configuration management tools obsolete, since it provided a means for you to package your application, code, and configuration in a Docker container that would then run inside the infrastructure provisioned by the IAC tools. A classification of infrastructure automation tools. Fast forward to 2020, and it is easy to feel lost as a DevOps practitioner when faced with the multitude of infrastructure automation tools available. One way to differentiate IAC infrastructure as code tools is by looking at the layer at which they operate. Tools such as CloudFormation and Terraform operate at the cloud infrastructure layer. They allow you to provision cloud resources such as compute, storage, and networking, as well as various services such as databases, message queues, data analytics, and many others. Configuration management tools such as Puppet, Chef, Ansible, and SaltStack typically operate at the application layer, making sure that all the required packages are installed for your application and that the application itself is configured correctly, although many of these tools also have modules that can provision cloud resources. Docker also operates at the application layer. Another way to compare IAC tools is by dividing them into declarative versus imperative categories. You can tell an automation tool what to do in a declarative manner, where you describe the state of the system that you are trying to achieve. Puppet, CloudFormation, and Terraform operate in a declarative manner. Alternatively, you can use an automation tool in a procedural or imperative manner, where you specify the exact steps needed by the tool to achieve the desired system state. Chef and Ansible operate in an imperative manner. SaltStack can operate in both declarative and imperative. So let's think about the difference between declarative and imperative. So let's look it up. I didn't get a good sense of it just by reading that. Okay, differences between the declarative and imperative models can be summed up in one sentence. Imperative focuses on how, and declarative focuses on what. In contrast, imperative programming, so in an imperative model, we have to specific each command required to configure a system. In a declarative model, we just specify key value pairs, usually that describe what we want, and let some other system worry about the commands to make it so. So I would prefer a imperative model over a declarative model. So it looks like Chef and Ansible are imperative. That is what I would want. I wouldn't want a declarative like Puppet, CloudFormation, and Terraform. I should probably get a lot better at Ansible than I am. Let's look at the desired state of the system as a blueprint for the construction of a building. Let's say a stadium. You use procedural tools like Chef and Ansible to build the stadium section by section and row by row inside each section. You need to keep track of the state of the stadium and the progress of the construction using declarative tools versus imperative. Now they called this something interesting, procedural. So I'm not sure if they meant to say imperative there instead of procedural, or if the two terms mean the same thing. You need to keep using declarative tools such as Puppet, CloudFormation, and Terraform. You first put together the blueprint for the stadium. The tool then makes sure that the construction achieves the state depicted in the blueprint. Given this chapter's title, we will focus the remaining discussion on infrastructure as code IAC tools, which can be further classified along several dimensions. One dimension is the way you specify the desired state of the system. In CloudFormation, you do it with JSON or YAML syntax, while in Terraform, you do it with the proprietary HashiCorp configuration language, HCL syntax. In contrast, Pulumi and the AWS Cloud Development Kit, CDK, allow you to use real programming languages, including Python, for specifying the desired state of the system. Another dimension is the cloud providers supported by each tool. Since CloudFormation is an Amazon service, it stands to reason that it focuses on AWS, although one can define non-AWS resources with CloudFormation when using the custom resources feature. The same is true for the AWS CDK. In contrast, Terraform supports many cloud providers, as does Pulumi. Because this is a book about Python, we would like to mention a tool called Troposphere, which allows you to specify CloudFormation stack templates using Python code, and then exports them to JSON or YAML. Troposphere stops at the generation of the stack templates, which means that you need to provision the stacks using CloudFormation. One other tool that also uses Python and is worth mentioning is Stacker. It uses Troposphere under the covers, but it also provisions the generator CloudFormation stack, templates. The rest of this chapter shows two of these automation tools, Terraform and Pulumi, in action, each working in a common scenario, which is the deployment of a static website in Amazon S3, which is fronted by the Amazon CloudFront CDN and secured by an SSL certificate provisioned via the AWS Certificate Manager ACM service. Note, some of the commands used in the following examples produce large amounts of output, except for cases where it's critical to the understanding of the command. We will omit the majority of the output lines to save trees, even though this is an electronic book, and enable you to focus better on the context. So I'm pretty interested in what they have to say about manual provisioning, but unfortunately I've got to stop it here. I'm just not feeling that tonight. I'm feeling really tired. I don't think I can continue any longer. Alright, but I have my bookmark here. Let's make sure that's the only one. It is. So that's going to be out of this video. See you in the next one.